is simultaneous linear equations. Simultaneous linear equations. Suppose you have given an equation. What is meant by linear equation before? What is meant by linear equation? System of linear equation. Consider the equations. You may solve two equations in two variable, three equations, three variable in 12th. So the first equation is the coefficients are given by a11 and the first variable is x1. Second term is a12 and x2. Likewise, I will continue the last term a1n xn is equal to b1. Okay, is equal to b1. So how many variables are there? कोणाकडे डिस्टर्बन्स नाही त्याने अनम्यूट ठेवला तरी हरकत नाही. घरात डिस्टर्ब नाही, सेपरेट they are having statements are there. What are the variables? Yes. Two. Okay. Only one equation I have written. How many variables are there? This is the first. This is the second. Like that, continue. I have highlighted the variables. Now tell me how many variables are there?
N number of variables.
N number of variables
are there. This is the first equation with the variables x1, x2, continue up to xn, n variables. Similarly, suppose the second equation I will write as a21x1 plus a22x2 plus continue. The last one is a21xn is equal to right side term is a constant b2. So likewise, I will continue. There will be m equation. am1, mth equation is given by am1 x1 plus am2 x2 plus dot amn xn is equal to bm. And this I will call as number 1. Suppose you have given system of m equations in n variables. Number of equations kiti ahet? You are having m equations and variables n. Can we write these equations in the matrix form? Because you are studied Cramer's rule, I think. Barabar na? Cramer's rule for solving the system of two equations, three equations. Suppose if you are having a more number of equations, in that case, we are using, see again students are joining at it's 10:39. If you are using Google Classroom, then it's okay. So next lecture onwards, I will not admit after 10:30. That's clear. Okay. These are the m equations in n unknowns. We can write these equations in the matrix form. We can write these equations in the matrix form. First one matrix that is called as a coefficient matrix, and second one matrix multiplication form. I will write this one is equal to right side matrix. Okay. Now for the first matrix, you have to write the coefficients of the variable. First row. What are the coefficients? I will highlight with the different colors. See.
A11,
A11,
A12,
continue up to A1n.
A1n.
First row, A11, A12, dot, that means continue. There are n columns, A1n. And what are the variables? Variables you have to write in the second one, x1, x2, dot, last variable is xn, equal to b1, first equation. Second equation, a21, a22, continue, a2n, b2. Is it right? Now continue, the last one, am1, am2, dot, amn is equal to continue, the last one is a bm. So what is the, suppose the first matrix, okay, the first matrix I will denote as a capital A. The first matrix I will denote as a capital A. Second matrix I will denote as a capital X. And the right side matrix I will denote as a capital B. And suppose this is number 2. What are the notations if required? This matrix A is nothing but this. Matrix X is nothing but this. Matrix B is nothing but this. Okay. What is the order of the matrix? What is the order of the matrix A? Sanga. What is the order?
M cross N.
Yes, there are m rows, n columns. What is the order of the matrix X?
N cross 1.
N cross 1. So the resultant is m cross 1. Now for 1, suppose I will go in the reverse order. I will go in the reverse order. You know how the matrix multiplication is defined. How the matrix multiplication is defined? I will use different color, then you will get idea. Multiplication of the row, this one and this column. Only one I will write here. Huh? So if you take a multiplication, first element is A11 into X1. That is the first element. So not necessary to write. For your understanding, I am writing. Plus, next element is A12 X2. Okay. Plus A12 X2. Continue this multiplication. Now the last one is A1n Xn, first element, plus A1n Xn is equal to, what is the corresponding element? Right side equality, that is a B1. That means if you simplify, you will get above system of equations. The same equations you are representing in the matrix form. And this system is called as system of non-homogeneous linear equations, linear m equations in n unknowns. I have used the word non-homogeneous. So here I will write, okay. This is a system of non-homogeneous equations. Okay. Now, so when you are writing this system in the matrix form, so this first matrix I am denoting as A, and that matrix is called as a coefficient matrix. That matrix is called as a coefficient matrix. Now the second one, this matrix is called as a matrix of unknowns. So this matrix having only unknown, na? This one is called as a matrix of unknowns. And the last one, this matrix is called as a constant matrix because you are having a constant term to the right side. This is called as a constant matrix. Okay, this is only representation of the given matrix. Now, next we are going to define one more matrix. Then the matrix which is obtained from coefficient matrix and matrix of unknown. First, I will write a matrix. So first, I will take up. Okay. The first one, if any questions are there, that simultaneously we can ask. So I will write the coefficient matrix as it is. A11, A12, A1n. These are the elements of the coefficient matrix. Second one, A21, A22, continue, A2n. And if you continue like this, last one is AM1, AM2, and last one, AMN. So this is a coefficient matrix. Now for this matrix, I will attach one more column. So for this matrix, I am going to attach one more column, and that column is nothing but the constant matrix. And what are the elements? B1, B2, continue, BM. बरोबर आहेत का बघा? Okay. Now this matrix I will denote by a symbol. I will write in square bracket A comma B or A slash B, whatever notation you can use, A comma B. And this matrix is called as, augmented matrix. This matrix is called as augmented matrix, and this matrix is obtained from a given matrix or from a coefficient matrix by attaching one more column to that, and that column is a constant matrix. So to make a difference between a matrix A and augmented matrix, I will use a vertical line. This is a separation. Now here, suppose I have to hide this last column. Is it possible? समजा मी शेवटचा कॉलम तुम्हाला जर दाखवला नाही, जस्ट अ मिनिट, इज इट पॉसिबल और नॉट? आई विल सी हाउ टू हाइड समथिंग हियर. दिस वन, open field. Okay, suppose if I am not allowing column number m, म्हणजे कशाबद्दल बोलतो, I will highlight this one. If I hide this column, म्हणजे तुम्हाला ते दिसत नाही समजा ग्रेत, आता मला हाइड करता येणार नाही. Okay, if you are not going to see the last column, you are getting a matrix A. बरोबर आहे? If you are allowing the last column, you are getting an augmented matrix AB. So to reduce our work, we are defining the new matrix, which is called as augmented matrix AB, which is obtained from a given matrix, by attaching one more column to that, and that column is a constant matrix. This is called as a augmented matrix. Okay. So up to this only we have seen some definition and how to represent the matrix. Now the question arises. I will start with some simple examples. Okay. Suppose you are given one set of example, that is x plus 3y is equal to 4, and suppose 3x plus 9y is equal to 1. This is a 1, 2 by 2. Okay. And the second example, suppose x minus y is equal to 1, x minus y is equal to 1, x plus y is equal to 2. And question is, solve the equations if possible. What is your opinion? दोन्ही पण सेट तुम्हाला सोडवायचे आहेत. Think on that. I will give 2 to 3 minutes. Two sets are given, and I think this is a system of non-homogeneous equation, na? Okay, before proceeding to that, when this system becomes homogeneous, or what is your idea about homogeneous system of equation? What is meant by homogeneous? You reply. If you interact, then I will get interest to explain the things. Your answer may be wrong. It's okay.
All the constant terms are 0, sir.
Yes, all the constant terms are 0. That means B1, B2, Bm if 0, that is called as a homogeneous. I'm asking why these are become homogeneous if constant terms are 0. ओमकार, समजा तुम्ही B1, B2, Bm 0 घेतला तर homogeneous होणार म्हणते. का होणार? Why? चुकू द्या, काय वाटतंय तुम्हाला? Homogeneous, what that word indicates? Quick, it's 7th lecture. I think other division they have completed first unit. Quickly reply na. Homogeneous म्हणजे काय? आता कोणतरी उत्तर ओमकारच सांगितलं ना, ओमकार भोसले?
No, sir.
ओके, ठीक आहे. कोणतरी
Sir, it has trivial solutions.
तुम्ही पुढचं सांगा लागलं, कुठेतरी शिकलाय असं होतंय. मग ट्रिवियल सोल्युशन नो. For homogeneous, always there is one solution which is called as a trivial. I am asking, okay, here I will write B1 is equal to 0 is equal to B2 is equal to Bm. तर ह्या सिस्टीमला आपण homogeneous म्हणतोय. We call this system as a homogeneous. My question is why? You told when that system becomes homogeneous. So my question is why it becomes homogeneous. What is the definition of homogeneous? Okay, I will write one equation. X square plus 2xy plus y square equal to 0. This is an equation in two variables. What are the variables? X and y. Is it right? These are this is the equation in two variable x and y. Is it this equation is homogeneous? We are studying non-homogeneous. I will come to the non-homogeneous. Is this equation is homogeneous? Homo means what? Kavita, what is your opinion?
Sir, I guess it's not homogeneous.
This one is not homogeneous. Okay. Why? You
Yeah.
are guessing the answer only. You don't know exactly.
Because there are two different terms, x and y.
Okay. Two variables are there. That's why it is non-homogeneous.
Uh,
But when one answer is there, B1 is equal to 0, B2 is equal to 0. So there are n variables or n terms. Now still they are telling the homogeneous then. They have same degree. That's it. Razin, Momin, given answer in the chat box. So degree of the first term किती आहे सांगा? 2.
2.
2, sir.
Degree of the second term means you have to count the degree of variable and you have to add. So its degree is 1 and 1. What is the degree then? 1 plus 1. Extra 1 and y 1. Second also 2. Okay. So the last term, the third term also 2. What about the right side term? What is the degree? That is important. What is the degree? I will write this degree as a 2 and this equation becomes homogeneous. This one is wrong. This is correct answer. What is the degree of the 0? Right side term. All of you are interested in theoretical formula? Degree is 1. Okay, one answer is 1. Now see, kon dila answer mal naam lakshat aala nahi. Already I written the answer is homogeneous. And the definition of homogeneous means homo means same. If all the terms having same degree, then that equation is called as a homogeneous. Now I am asking, or I already written degree of the right side term is 2 because already I written homogeneous. How that degree becomes 2 for 0? Not able to tell? Okay, I will. Anyone? If no, okay, I will write this term as already 0 is there. 0 into x square. Chalel ka? Chalel ka? Yes or no? Tar sanga ki 0 into anything is 0.
Yes, sir.
Means
Yes,
0
sir.
into x square, you can adjust that term. So when you are writing 0 into x square, then again its degree becomes 2. So that's why this is an example of homogeneous. Now here in this example, degree of highlighted term you see. I have shifted to the system of linear, this part, okay? This one. So degree of x1 is 1, degree of x2 is 2, continue, degree of xn is, yes, what is the degree? So here I may write x1 raised to 0. So in this case, all terms don't have same degree. कारण xn पर्यंत 1, 1, 1 and you are having 0 for the last one. But instead of that, if this becomes 0, I will write 0 into x1. खूप अवघड चाललंय. अवघड चाललंय? Is it clear or not? I am explaining the definition of homogeneous and non-homogeneous. Okay. So if B1 is there, then degree of that term becomes 0. So that's why it is a non-homogeneous system. Okay. Now, when the system of non-homogeneous equations are given, so that's why I started with the particular cases. Now, what is the solution or what is your opinion here? What is the solution? That is the first case and second case. Sanga. You have to work with pen and paper. Huh? So I'm asking directly solution. What is the solution? No answer? Okay. One more term I will write. This equation second equation for the first case. Second equation for the first case, I will write x plus 3y is equal to 1 by 3. चालेल का नाही सांगा पहिल्यांदा.
Yes,
I am
sir.
multiplying that whole equation 1 by 3. Now after that, now here x plus 3y and x plus 3y, and these two equations are telling that x plus 3y is equal to 4 and x plus 3y is equal to 1 by 3. That means you are getting 4 is equal to 1 by 3. शक्य आहे का?
No, sir.
No, sir.
No.
This is not possible, which is a contradiction. That means in this case, if you consider these two equations simultaneously, there does not exist a solution. What is meant by solution first? Okay, let us see the definition. What is meant by solution?
Which satisfies the
Yeah,
equation.
you have to find the values of the variables which satisfy the two equations simultaneously. But in this case, solution exists. In this case, solution exists. I think you have studied Cramer's rule. Cramer's rule, I will write the formula. While finding x, you are writing, delta x upon delta, something like that, correct?
Yes, sir. Delta x
Delta
by
x upon
But
delta
delta.
r y is equal to delta y upon
by
delta.
delta.
Okay. So whether you have studied when solution not exist, what is the condition?
When delta is equal to 0.
When delta, sorry, this one, delta is equal to 0. That means what you are studying? Determinant of the coefficient matrix equal to 0. Correct, na? Is 0,
Yes, sir.
then no solution. So here I want to conclude that when the system of, these are the rough calculations for your understanding, when the system of Ax equal to B, the system of non-homogeneous, when I am writing Ax equal to B, that means you have to consider this one, okay? These equations together. So Ax equal to B, this equation does not possesses always solution. प्रत्येक वेळी solution असेलच असं नाहीये. Every time solution exists or not, that you have to decide. So up to 12th you have studied 3 by 3 matrix or 2 by 2 matrix, and determinant easily can be evaluated. Suppose 4 equations, 5 equations are given, then it's become a complications to identify whether solution exists or not. When solution exists, we say the equations are consistent. X equal to B is consistent. Consistence implies solution of X equal to B exists. ज्यावेळी solution exist होतो त्यावेळी आपण consistent म्हणणार, and X equal to B is inconsistent means solution of X equal to B not exist. X equal to B not exist. So what is the condition, or under what condition the solution exists? So that we call as condition of consistency. That we call as condition of consistency. This is a very important for GATE or multiple choice questions. Condition of consistency. Just a minute. Condition of consistency. So under what condition the system of equation Ax equal to B is consistent? So when I am writing Ax equal to B, you have to understood. So let Ax equal to B be the system of m linear equations in n unknowns, and this system is non-homogeneous. N unknowns given by equation number 1. What What is your equation number 1? The beginning, okay? Equation number 1, and that same thing, equation number 1, we are representing in the matrix form as a Ax equal to B. Is a consistent, म्हणजे solution असेल, is consistence if rank of matrix A, you know how to find rank of the matrix A by using echelon form, and rank of the augmented matrix AB, rank of the augmented matrix AB. If these two ranks are equal, in that case, we can say the given system of equations or given equations are consistent. Now, how to find the rank of A and AB in one stroke? If you close the last column, I have to hide something should be there. समजा जर तुम्ही लास्ट कॉलम ह्या मॅट्रिक्स ए बी, माझा कर्सर दिसतो ना, हा मॅट्रिक्स ए बी चा लास्ट कॉलम इन इचेलॉन फॉर्म, इफ यू क्लोज you will get a rank of A. If you allow the last column, you will get a rank of AB. If both ranks are same, then the given system of equations are said to be consistent. And suppose these two ranks are equal to R. Me assume करतोय rank is R. Now further case number 1. Further case 1, if R is less than 1. So what are the different possibility here? One is R less than n, R equal to n, R greater than n. Whether it is possible? The answer is no, because rank is minimum of m and n.
No.
That is not possible. Only two possibilities there. So from that I am taking R is less than or equal to n. Then Ax equal to B, म्हणजे जो काही दिलेला सिस्टीम आहे, Ax equal to B has infinite solutions. Has infinite solutions. How to find that I will explain through example. Infinite solutions, and parameters is given by, you have to identify the parameter. Parameter is given by n minus R, where n is number of unknowns, R is, it's almost 11 o'clock, still students joining. Who is that? Jesse Kumar. Nonsense. Okay. Okay, parameter is equal to n minus R, where n is nothing but the number of unknowns, R is nothing but the rank of the matrix. So this formula you have to remember while solving or while finding infinite solutions, you have to consider this. Okay, so this is a case number 1. That is the first possibility. This case we have considered. So the second case is case number 2. If R is equal to n, means rank is equal to number of unknowns. If rank is equal to number of unknowns, in that case, rank is equal to number of unknowns, then the system of equation, or I will use the word system of equations represented by Ax equal to B, has unique solution. Okay, remember the cases. First case we have discussed, if rank is equal to less than number of unknowns, in that case we are getting infinite solution. If rank is equal to n, you are getting unique solution. So for examples point of view, you have to remember the concept. First thing, we can represent the given equations in the matrix form. After that, write an augmented matrix. From that, you have to find rank of A and rank of augmented matrix. If rank of A is equal to rank of AB, we can conclude that the given system has solution. And if solution exists, then only you have to discuss case 1 or case 2. So directly, suppose if you are getting rank of A is not equal to rank of AB, what should be your conclusion?
Solution does not exist.
Solution does not exist and you have to stop there only. But my experience is that in the examination, while correcting the answer sheets, students are concluding that rank of A is not equal to rank of AB, so solution does not exist. And again, still they are finding the solutions. So in that case, marks द्यायला पाहिजे. You have not understood the concept, na? Solution does not exist. That is the end conclusion. That's why I'm telling don't compare length and mark for at least mathematics subject. So for 8 mark, I have to write 2 or 3 pages, not necessary. 4 lines are also sufficient. And to the point answers you have to give. Okay, I will discuss examples. Any doubt, any questions you want to ask up to this? If something is not clear, when I will solve the examples, you will get more clear idea. Okay, silence means no any questions. I will discuss the example. So example number 1. Don't write first example. I will give sufficient time. You can take down. First example, listen carefully. So my handwriting is small. You can zoom your screen. Okay. Test for consistency. म्हणजे काय? Test for consistency. Test for consistency and if possible, solve them. If possible, solve them. The equations are, first equation is x plus y plus z equal to -3. Second equation, 3x plus y minus 2z equal to -2. And third equation, 2x plus 4y plus 7z is equal to 7. How many equations are given?
3.
3 equations, 3 unknown. Test for consistency means when the system of non-homogeneous equations are given, first you have to verify whether solution exists or not. Here see the word if possible means if solution exists then solve. If solution exists then solve. If no solution, you have to conclude that given system of equation not possesses a solution. That's it. So first I will represent the given matrix in the given equation in the matrix form. So first listen carefully. We can write the given equation in the matrix form. First one is a coefficient matrix. Second one is a matrix of unknowns. Third one is constant matrix. Is it right? What are the unknowns here? X, Y, and Z. These are the unknowns. First equation, the coefficients. Now see, this one I will highlight. I am representing this matrix. Coefficient of X is, tell me.
1.
1. Coefficient of Y.
1.
Coefficient of Z.
1.
-3. Okay. So like that. Second equation we can write 3, 1, -2, and -2. 2, 4, 7, and 7. Okay. And this system of equation I am representing as Ax equal to B. Suppose when I am writing say means I am using the notation. So here the matrix A stands for the coefficient matrix. Matrix X stands for the matrix of unknown. And matrix B stands for constant matrix. Not necessary to mention separately. Now from this I will write. Some author may use the same system. They represent same equations in the matrix form as it is. But for mathematics you have to write minimum in minimum time. So that's why I will consider the augmented matrix. So consider the augmented matrix, how it is noted in square bracket A comma B, in square bracket A comma B. And this augmented matrix can be obtained by or from coefficient matrix by attaching one more column. First, I will write 1, 1, 1, 3, 1, minus 2, 2, 4, 7. And for this matrix, you have to attach one more column, that is minus 3, minus 2, and 7. Okay. So for my understanding, I am using one faint line. You can use pencil for this. Why I am using this line? Means if I am not allowing the last column, highlight karala pahije. If I am not allowing the last column, you will get a matrix A. Highlighted column you have to skip. If I allow the last column, then I am getting a augmented matrix AB. So for this line, whatever color I use, you can use pencil for that. So I have to identify rank of A and rank of AB. Okay, rank of A and rank of AB. Just a minute, 1, 2, 3. Now, you have to reduce this matrix to the echelon form. I will use the 3 columns here. Here only I will simplify. This number 1. Tell me the first one. Suppose our target is to reduce this matrix to the echelon form. So this highlighted part I will skip. You have to fix the diagonal entry. Echelon form. So morning someone has asked the question, not understood the echelon form. Once again explain. Suppose this matrix AB I have to reduce to the echelon form. This also I will skip. Okay, this also I will skip. This matrix AB I have to reduce to the echelon form. So what is the elementary transformation? And one more thing, for echelon form, leading diagonal elements to reduce 1 is not a mandatory. That should be a non-zero. So here directly you are getting 1, 1 as a 1, this element as a 1. Now my target is the elements which are below to A11, these elements you have to reduce to 0 by using R1. Tell me the transformation.
R2 minus 3R1.
3R1.
By
R3 minus 2R1.
R2 minus 3R1 and R3 minus 2R1. बरोबर आहे? So the new equivalent matrix, not equal. New equivalent matrix. These 2 transformations shows that change for second and third row only. Change for second and third. First row no change. That is 1, 1, 1 and minus 3. So first row no change. Multiply first row by 3 and their subtraction. Tell me 3 minus 3. 1 minus 3. Minus 2 minus 3. Minus 2 plus 9. Correct, na? Next, you have to multiply by 2. Multiply by 2 and then subtraction. 2 minus 2. 4 minus 2. Sanga element zara. Yes. 7 minus 2. 7 minus
1.
minus plus 6. Minus minus plus
13.
Yes. 13. Okay. After the first. And one more thing. Remember, if you apply a single column transformation in a system of equation, you will get a wrong answer. लक्षात आलंय? Column transformation कुठल्याही परिस्थितीत वापरायचा नाही. So again, this is a diagonal entry. This is a diagonal entry. So my target is, after getting the elements below A11 to 0, the elements below A22, this element you have to reduce to 0. Already they are given in the multiple. What is the transformation? R3 you have to change. Patkan. You have to use R2.
R2 plus R3.
R3 plus R2. Okay. While writing. Because you are changing R3, not R2. You are changing R3. So only one transformation. So the new equivalent matrix. First row no change. 1, 1, 1 and minus 3. Second row no change. 0, minus 2, minus 5, 7. Addition of these two, 0, 0, 0, and 20. Is it right? Now, first condition. This is a diagonal entry. So for the echelon form, the elements below diagonal must be 0. मिळालेत का? The elements below diagonal must be 0. मिळालेत का? First condition, yes or no?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
After that, what you have to think? First non-zero element in the first row. Below to that must be 0. आहे na?
Yes.
Sure.
Yes, that condition also satisfied. Now the second non-zero element, if required, I will use some faint color. Which color I am using? Okay, this one. समजा हा तुमचा फर्स्ट नॉन झिरो एलिमेंट. पुन्हा एकदा सांगायला लागलो, मराठी सांगतो मी. बिलो टू दॅट ऑल एलिमेंट्स 0. ओके. सेकंड नॉन झिरो एलिमेंट, बिलो टू दॅट ऑल शुड बी 0. नाउ नेक्स्ट, दिस एलिमेंट इज अ नॉन झिरो. ओके, त्याच्या खाली एलिमेंटच नाहीये, पण त्याच्या लेफ्ट साइडला जिथं काही लाईन आलेल्या आहे, द झिरोज मस्ट बी कवर्ड बाय द लाईन्स. तिथे एखादा नॉन झिरो टर्म असेल, then that is not a echelon form. Remember, the elements covered by line must be 0. If non-zero element is covered, then that is not the echelon form. Now in this case, is it echelon form? Hi Anna.
Yes.
Yes, this one is a
Yes,
echelon
sir.
form. So what is the rank of A and rank of AB from this? Just to see. कौन सांगते? What is the rank of A? So for your understanding, I will again draw a line. So this is a matrix AB. So here, first I will write rank of AB. Here, rank of the augmented matrix AB किती आहे? सगळा मॅट्रिक्स गृहीत धरायचा, काही स्किप करायचं नाही.
Rank of A will be 2 and rank of AB will be 3.
Rank of AB is 3 because there are 3 non-zero rows. बरोबर? Now after that, suppose you have to find the rank of A. पुन्हा rank A matrix काढायची गरज नाही. So purposely I will use some dark color. तरी पण तो दिसू शकतोय. Okay. आता समजा, means I am hiding this. Don't consider the last column. What is the rank of A?
2.
Don't consider the matrix last column. So again, if you not allow the last column, the remaining matrix is in the obviously echelon form, and number of non-zero rows in this case is 2. So the rank of A is 2. Okay. Now you can use, that's why I'm using here AB. That left to you whether you are using or not. Now I will allow that last column. Is it clear? काय doubt आहे आता? No. Rank of A is not equal to rank of the augmented matrix AB. This implies solutions are inconsistent. Means solution exist होणार नाही. Given equations are inconsistent. That is the final conclusion. Inconsistent. That is the final conclusion. That is the end of the example. So you can take down. जर लिहिला नसेल तर लिहून घ्या. We write in the matrix form. First one is a coefficient matrix. Second one is a matrix of unknowns is equal to constant matrix. Now the unknowns are x, y, z. If x1, x2 given, that you have to take unknowns. Coefficients 1, 1, 1, and 3. 1, 2, 3, and 4. 1, 4, 9, and 6. Okay. And suppose that I will denote as a ax equal to b, suppose. Ax equal to B say. Suppose this is number 1. Now, the augmented matrix AB is given by or is obtained by attaching one more column to that matrix. So the coefficient matrix is 1, 1, 1, 1, 2, 3, 1, 4, 9, and one more column you have to attach, that is 3, 4, and 6. Okay. Now again, fix the diagonal entry. Now in this case, the diagonal entry is 1, 2, 9. Our first target is to reduce these two elements by using R1. Tell me the transformation.
R2 minus
R2 minus
R1,
R1, R3 minus
R2
R1.
minus R1.
Yes, R2 minus R1. R1 is the key row and R3 minus R1. So the new equivalent matrix, I will little bit scroll up. So new equivalent matrix where first row no change, that is 1, 1, 1 and 3. Second row subtraction, 1 minus 1, 0, 2 minus 1, 3 minus 1, 4 minus 3. Is it right?
Yes, sir.
Next, R3 minus R1, 1 minus 1, 4 minus 1, 9 minus 1, 6 minus 3, that is 3. Again, this is your diagonal entry. Okay. So the next, the elements which are below to A22, you have to reduce to 0. What is the transformation? By
R3 minus
R3
3
minus
I3 minus 3 R2.
R3 minus 3 times R2. So the change in third row only. First two rows, no change. 1, 1, 1, and 3. 0, 1, 2, 1. 0, 0, 0. Something I written wrong? Okay, just a minute. See, check the calculations. Something here I have written. 0, 0. What is the value? 2, na?
2.
Yes, sir.
And 0. Yeah. Now, this is your diagonal entry. Now, if required, I will use the lines, this one, to separations between A and AB. Okay. Now, what is the rank of AB? Pahila sagla matrix allow kara. What is the rank of AB?
3.
Is 3. Okay. And if you skip the last column, you will get A. What is the rank of A?
3.
Yes.
3.
Rank of A and rank of AB both are equal here. Okay. Rank of A and rank of AB both equal. Therefore, the given equation or the given system is consistent. So that part I will mention here. So here rank of A is equal to rank of AB, and that is equal to 3. And how many unknowns are there? This 3 is equal to number of unknowns. Barabar hai na? This 3 is equal to number of unknowns. What is the conclusion? Yes. R is equal to N, or first one, rank of A is equal to rank of AB. Therefore, the given system of equations are consistent. म्हणजे solution exist होतोय. Consistent. If solution exists, then next you have to decide whether the solution is unique or infinite. What is the case here?
Unique solutions.
Okay. Both the statement I will write combine. So this implies given equations are consistent. Given equations are consistent with unique solution. म्हणजे तिथं आता तुम्हाला unique solution मिळतोय. Now suppose this matrix, whatever the last rank you identify, na, so that matrix I will number as a 2. That matrix I will number as a 2. So from 2, the equivalent equations are म्हणजे reduced जे इक्वेशन मिळणार आहे ते इक्वेशन्स काय असणार इक्वेशन्स आर फर्स्ट वन बाय
X, Y, Z equal to 3. Y,
plus y
Z,
plus z equal to value is missing here
3.
3. I will use small 1 to this equation. Okay. Second one.
Y plus 2Z equal to 1.
Y plus 2z equal to 1. I will use
2Z equal to 0.
2. Now third one, 2z equal to 0. This implies what is z?
0.
0.
And you have to use back substitution. Means put z is equal to 0 in equation 2. So put z is equal to 0 in equation 2. So what you will get? Y plus
Equals
g
to
1.
is equal to 1. So this y is equal to 1. Next, put
X is equals to 2.
yeah, y is equal to 1 and z is equal to 0 in equation small 1. That is x plus value of y is 1 plus z equal to 3. So this implies x equal to 2. Now the solutions. First one, z is equal to 0. Next, y is equal to 1 by using back substitution and x is equal to 2. Okay. Now, here only you can check your answer, whether your answer is correct or not. So here only you can check your answer. So how you have to check? Here finally I will write the conclusion and then I will verify that. So thus the solution is x is equal to 2, y is equal to 1 and z is equal to 0 is the required solution. I will go to the given equations. Okay, I will use some different color. Now here, so suppose you are verifying the equations. What are your values? X is equal to, yes, x is equal to 2, y is equal to 1, z is equal to 0. So first equation 1 becomes, substitute the values. X is 2 plus y is 1 plus z is equal to 0. 2 plus 1, that is RHS. We started with suppose LHS. Equation 2, LHS is 2 plus 2 into 1, 2 plus z is 0. That is 4. That also RHS. Second also satisfied. Third one, x is 2, LHS is equal to x is 2 plus 4 into 1 plus 0 equal to 6. So all equations are satisfied. So you only conclude here that your answer is correct and you can share with your marks. Okay. So today I will stop. If any questions are there, I will take a questions. Otherwise, I will shift to the attendance.